Okay, now the last measurements and we can go back.
What are these measurements for, Sam?
Well, I'm measuring the humidity right now, so that we can know how the weather is going to be and understand how it contributes to the fact that the climate change is affecting the Arctic more than other regions.
Oh, so that's how it is. Say, I know that clouds consist of water and that it rains down when the clouds raise up, but how are weathers really created? I mean, like, the more specifics.
Okay, so let's go through the different weathers. You know that warm air is less dense than cold air, which is how a hot air balloon works, right?
Yeah.
Well, these low pressure, which is caused by warm air, and high air pressure, which is caused by cold air, also influences the weather. High pressure air, or cold fronts, creates sunny weather, as the cold air is warmed up by the sun and comes down, and since the cold air is dry and contains less water vapor, and warm air doesn't condense much, clouds can't be created, as there isn't enough humidity. These conditions are also called anticyclones. We usually have sunny weather in spring and summer, since that's the time when our side of the Earth, the northern hemisphere, gets concentrated sunlight, as the Earth is 23.5 degrees tilted, so that the sunlight that hits the southern hemisphere is more spread out, which reduces the warming of the air. Sunny weather can also form when the area is between fronts or is far away from a storm.
Wow, I didn't know that. I always wondered why it's more sunny in summer.
Yeah, quite cool, right? Now to cloudy weather. Cloudy weather forms, as you can predict, from low air pressure or warm fronts. Warm fronts are created from the air that rises from the surface. As it rises, it cools down and creates water vapors, as cold air can't hold as much water vapor as warm air can, which in turn form clouds. Warm air can rise from different reasons, like the sun warming up the air above the ground which rises up, or when the air is traveling towards a hill or mountain. And since it can't go into a hill, it rises along the side, which is often how stratus clouds are created. Then there is convergence, which usually happens in low-pressure areas. Convergence is when streams of air flowing towards each other are to rise when meeting each other, or converge. This can cause cumulus clouds and showery conditions.
Oh wow, that is very interesting. But I heard that there are a lot of different cloud types, like the stratus clouds or cumulus clouds you just mentioned.
That's right. The different types of clouds can be divided into 3 different groups: low-level clouds, mid-level clouds, and high-level clouds. Low-level clouds have a base at an altitude under 2,000 meters, and the 2 main types are stratus, which develops horizontally, and cumulus, which develops vertically. Stratus clouds are flat and spread out, which is implied by the name that comes from Latin and mean flat or layered, and are usually white or uniform gray. They can appear on the surface as mist or fog, and usually bring a little to no rainfall. But if it's thick enough, it can produce a light drizzle. Then there are stratocumulus clouds. Stratocumulus clouds are patches or clumps of clouds, also implied by their name. Stratus meaning flat, and cumulus meaning heap, and vary from white to dark gray. They are the most common clouds recognized by their lump base. They usually have gaps between them, but can also be joined together. Stratocumulus clouds are usually mistaken for rain clouds, but actually it's quite rare to even get a drizzle from them, if anything.
Oh, does that mean that when I sometimes thought it was going to rain and it doesn't, it was a stratocumulus cloud?
Maybe.
I guess I'll just have to look more carefully at the clouds next time. So what other clouds are there?
There is also cumulus clouds.
Oh, the one that is formed by air streams flowing towards each other.
Yes, cumulus clouds, cumulus meaning heap, usually appear in fair weather, but if conditions allow it, cumulus clouds can turn into cumulus congestus or cumulonimbus clouds, which can produce showers. Now to the last one, cumulonimbus clouds. Cumulonimbus clouds, also known as the king of clouds, are rain clouds, or better said, thunderclouds, also implied by their name, cumulus meaning heap and nimbus meaning rain. Cumulonimbus clouds are menacing-looking, multi-layered clouds, extending high into the sky in towers. Their base are usually flat with dark wall-like features hanging underneath, and may only hang at around 200 meters high. Cumulonimbus clouds usually form from cumulus clouds that slowly grow over hot areas till they can store the same amount of energy as 10 Hiroshima-sized atom bombs.
If my brother heard this, he would be grinning.
Yeah, that I can believe. Well, cumulonimbus clouds are associated with extreme weathers like torrential downpours, hailstorms, lightning, and even tornadoes. Individually, cumulonimbus clouds, or cumulonimbus cells, usually dissipate within an hour, making a short-lived, heavy rain. But multicell or supercell storm possess many cumulonimbus clouds, so the intense rainfall can last longer. Lastly, there is nimbostratus clouds, which are also rain clouds. Like all rain clouds, it's dark and gray. It produces a continuous rain or snow, if it's cold enough. It forms through the thickening of altostratus clouds, which are from the mid-level layer of clouds. Now let's continue to the next layer. Mid-level clouds are usually found at an altitude between 2,000 and 6,000 meters and are given the prefix alto, which means height. The two mid-level clouds are altostratus clouds, as I just mentioned, and altocumulus clouds. Altostratus clouds are usually composed of water droplets and ice crystals. They are spread over a wide area and are featureless, being thin enough in some parts to allow you to weakly see the sun behind the clouds. Altostratus clouds usually form when a cirrostratus descends from the high-level layer and, as I mentioned earlier, can form nimbostratus clouds. Now, altocumulus clouds. Altocumulus clouds are small patches of clouds called cloudlets.
Quite a cute name.
They usually exist in the shape of rounded clumps, but their form can vary. They are made out of a mix of ice and water, giving them a slightly more ethereal appearance.
Well, I guess that makes sense, since I think I'd like cute little clouds prettier than big clouds.
I guess. Altocumulus clouds form from breakups of altostratus clouds, or from mountainous terrain that produce atmospheric waves. You can already guess which weather is associated with it.
Yeah, I mean, such small clouds can't really make much.
Yup. And even if rain falls, it would evaporate before reaching the ground. Now, high-level clouds. High-level clouds are given the prefix cirro, which means curl of hair, and are at an altitude of over 6,000 meters. Firstly, there are cirrus clouds. Cirrus clouds are short, detached, hair-like clouds. They are wispy, with a silky sheen. During the daytime, they are whiter than other clouds, and when the sun is setting or rising, they take on the colors of the sunset. Cirrus clouds are completely made up of ice crystals, which give them their white color. They can also be created by contrails, the vapor trails that planes leave behind.
I always wonder about those streaks and how they are formed.
Cirrus are often formed in advance of a warm front, indicating a change in weather. Then there are cirrostratus clouds. Cirrostratus clouds are transparent clouds that cover large areas of the sky and are made out of ice crystals. Because of the ice crystals, when sunlight or moonlight go through the hexagon-shaped ice crystals, the light gets dispersed or refracted, similar to light going through a prism, and there then seems to be a halo around the sun or moon. This halo can indicate that a warm front bringing rain is coming. Since cirrostratus clouds are usually generated at the forefront of frontal weather systems, they can be used to predict the weather in the next 24 hours. Now lastly, cirrocumulus clouds. Cirrocumulus clouds are like altocumulus clouds, but colder, made out of ice and supercooled water, which means that the water is still liquid even below 0 degrees. Also, cirrocumulus clouds can often prelude stormy weather.
So, I guess I need to pay attention if there is a halo around the sun or moon if I don't want to get drenched.
Yep.
So, how does weather forecast work?
Well, weather forecasting is more guessing than anything else. Of course, we need to take the data we collected from weather aircrafts and weather balloons into account. Do you want to know why weather aircraft were invented?
Sure, but it seems the test is finished. And it's getting dark. Should we head back now?
Yeah, you're right. How about I tell you about it on the way back?
All right.
So, in July 1943, a hurricane was heading towards Bryan Field, Texas. British pilots were receiving training there by the USAAF, which decided to evacuate the AT-6 Texan planes. The British pilots joked that the US planes were lacking structural strength, so Colonel Joe Duckworth flew AAT-6 into the eye of the storm, proving that it was possible. However, after that he flew into the eye of the storm again, this time with the meteorologist of the base.
So, was it a bet?
Yes, it was a bet.
Wow.
Yeah. Later in World War II, both the Axis and Allies converted bombers like the B-29, FW-200, etc., into weather surveillance aircraft. Bombers because they had long loitering time and range. After World War II, bombers were still being converted to weather surveillance aircraft, like the WB-29, WB-50, and so on. Later, turboprop aircraft like the C-130 and P-3 Orion were converted to weather aircraft.
So, did they only use propeller aircraft?
No, today the US use Gulfstream jets and the Soviets used the IL-28. However, only props are used to fly directly through storms because they can quickly adjust their propeller pitch, i.e. speed.
Why is that important?
Because in storms the wind speed varies a lot, and also very quickly. So planes have to change their speed quickly and often, so that they don't stall or overspeed.
Oh, okay. Then what do the jets do?
Well, most of these aircraft, including the jets, fly at high altitudes to keep an eye on the storm from above.
What do they do?
They drop bogies, which have sonar and measure the inside of a storm.
So, it's safer?
Yes, it is. That can't be said to the planes flying through the storm, though.
How about weather balloons?
Weather balloons are somewhere between high-flying aircraft and satellites. They float at high altitudes, sometimes up to 50 kilometers, take pictures, etc. But they are cheaper than planes and way cheaper than satellites.
Okay, I think that answers all my questions. Or most of it. We've arrived. I'm going to go to my room now. Want to finish that book that I started. Bye.
Bye. I'm glad to help.